The next important group that we will study, that is addition modulo n. First you do addition, then you find the modulo. Okay, so this is the point. So let me tell you what is the base set. In this group, what is the base set? So remember, this group is represented as Zn. What is Zn? Let me tell you, what is Zn? N is some natural number. Then what is Zn? In this situation, Zn will be all the remainders. Zn will be all the remainders of n. So can you notice what is Zn? Zn is basically all the remainders of n. All the remainders, okay, when divided by n. All the remainders when divided by n. Okay, so this is the idea. So this is the, okay, remember this Zn means this symbol Zn means for all the remainders when you divide by n. So can anyone tell me what is Z3? What is Z3? All the remainders when you divide by 3. All the remainders when you divide by 3. What is the Z2? All the remainders possible when you divide by 2. What is Z4? All the remainders when you divide by 4. So what is Z6? That will be 0 to 5. So this is the idea. So this is your Zn. Now, so this base set is clear to everyone. This base set is clear. Now the operation. The operation is this is the operation. We define the operation as addition modulo n. Addition, first you do the addition, then you find modulo, then you find the remainder modulo n. Okay, so this is the operation. So for example, if I give you, let's assume Z4, and the operation is addition modulo n. And what is n? N is 4. So this is the structure, remember. So you have Zn, which is the set of all remainders possible when you divide by n. Then all the remainder that are possible means 0 to n minus 1. Okay, and the operation is addition modulo n. Addition modulo n. So what this operation means? Can anyone tell me what this operation means? What this operation actually means? This is your operation. This means first you add a plus b, and then you find the remainder when you divide by n. Okay. So this is the idea. Addition modulo n. First you add and then you find that. So for example, let's assume this Z4 addition modulo 4. What this means? What is the base set? The base set is 0, 1, 2, 3. This is the base set, and this is your operation. First you understand the operation. Always start by understanding the operation. So tell me so tell me this one. What is this? Can anyone tell me? This will be first you add, then you find the remainder when you divide by 4. So if you do this, then this will be 4 mod 4 and 4 mod 4, that is 0. Okay, so that is 0. So this is the idea. So tell me what is this? What is this one? First you add, if you add, then that will be 5. And then you find the remainder. The remainder will be 1. So if you take any two elements, then is it closed? For example, if I take this element and this element, then what that will be? First you add, then you divide by 4. Remainder will be 3. So this is the idea. So now my first question, is it closed? This is 0, 1, 2, 3, addition modulo 4. My first question, is it closed? The answer is yes. The answer is yes, because finally remember, the final result will be this, because what you are doing, first you are adding and then you are finding the remainder. First you are adding, this is what you are doing. First you are adding, then you are finding the remainder when you divide by 4. So when you divide by 4, then the remainder possible are these, only these are the possible remainders. So the result will always be in this set. Okay, so this is closed. And what about associative? This is associative because this is simple addition. This is associative because actually this is simple addition, because your addition is associative. So this is actually addition followed by modulo 4. So first you add, then you find the remainder. So this is associative because this is simple, like more like addition. This is just like addition. This is similar to addition. Okay, next, what is the next property? What is the identity element? Can anyone tell me? What is the identity element? 0 is the identity element, right? For any element, this, because you are doing the addition, right? 0 is the identity element. You can check basically identity element, what it means. For all the elements, you can check 0 is the identity element because first you are adding, yes or no? Yes or no? For example, what is this? Can anyone tell me what is this? This is 2. What is this? This is 1. So the idea is very simple, that because remember, this has all the properties of addition. Remember this point. Remember this point. This has all the properties of addition because first you are doing the addition and then you are finding the modulo. So first you are doing addition. When you are doing addition, at that time you can clearly see 0 is the identity element. Yes or no? Why 1 is not the identity element? Can anyone tell me? 1 is not the identity element. Why? Anyone tell me why 1 is not the identity element? Because this is not equal to 3, right? Because this is not equal to 3. This is actually equal to what? This is actually equal to 0. So 1 is not identity element. So 0 is the identity element. What about inverse property? So your base set, you know, 0, 1, 2, 3. And this is the operation. So identity element, we got 0. Now tell me what is the inverse of 0? Identity element inverse will always be identity element. There is no problem. Remember, because identity element is inverse is always identity element. Okay, what else? What is the inverse of 1? Inverse of 1 means, what should I write here? What should I write here such that I get identity element, such that I get 0? What should I write here? Anyone? I should write 3 here, right? What should I do? I should write 3 here. Okay. What is the identity? What is the inverse of 2? What is the inverse of 2? So inverse of 1, that is 3. Inverse of 3, that is 1. Inverse of 2 means, what should I write here such that I get 0? What should I write? I should write 2. This is what should I write. So I can say 2 inverse is actually 2. Okay, so this is the idea. I hope this is clear. Is this clear? This addition modulo n. You can do this for any n. For any n you do, this will be a group. One more thing. Is it commutative? Is this commutative? Yes, this is commutative also. So this is actually a abelian group. Okay, so very simple. Now, remember, in general, let's see the general properties. What will be the general properties? If you have Zn, comma, addition modulo n, where n is some natural number. So for example, then in this case, what will be the base set? The base set will be 0, 1, 2, 3, and so on, n minus 1. This will be the base set. Okay. Now you tell me, so you already know all the properties. You can notice that this will be closed because final result is modulo n. So the final result, if you notice, that will be only this one of them. So this is closed. What about associative? Similar to addition, this is associative. What about identity element? Identity element will be 0. And okay, the fourth thing, this is commutative. This is commutative also. And this is interesting. 5. What is the inverse of some element? What is the inverse of A? What will be the inverse of A? For any element, what will be the inverse of this? You can check, that will be n minus A. But remember, 0 inverse will be 0. Okay, 0 inverse will be 0 for other, where A is not equal to 0. For all A, which are not equal to 0. 0 inverse will be 0 because 0 is the identity element. So 0 inverse will be 0. For the remaining, the inverse will be n minus A. Why? Because very simple, you can see what will be A inverse. So 0 inverse will be 0. If A is not equal to 0, for all A which are not equal to 0, what will be A inverse? So basically I am asking you, what should I write here? What should I keep here such that I get 0? This is the question. Okay, this simply means that what should I add here? What should I add here? Mod n such that I will get 0. It means, remember, this is mod n. It means this should be, n, right? Yes or no? Agree? This is mod n. So it means this should be n. So I should write here n minus a. Correct? Is it clear? Because n mod n will be 0. You already know. If I put n minus a, then what will happen? Then you know that n mod n, that will be 0. So that's the point. And this is your identity element. Okay, so this is the idea. So A inverse will be n minus a, but 0 inverse will be 0.